Hari Om. We will talk about the respiratory system and a few basic aspects of pranayama practices related with the respiratory system. The respiratory system is a most unique system in our body, and it is also one of the important system in our body. As such, all the systems in our body, they are important. But respiratory system is more important, is more unique because of the control of the respiration. As we all know that the process of respiration is independent. We do not need to control, we do not need to focus on the process of respiration. The process goes on automatically 24 hours a day, even though we are sleeping, even if we are working, the process will go on independently, automatically. But up to a certain extent, the process of breathing, the process of respiration can be controlled by our mind. It can be controlled by our will. We can modify the process of respiration up to a certain extent. So respiratory system is the only system in our body which is controlled automatically, and at the same time, up to a certain extent, our mind can control the process of respiration. This is the most unique thing about the respiratory system, and the practice of pranayama is actually based on this control of respiration. So, if your mind can control the process of respiration, then if you try to control the process of respiration, your mind can be controlled. So pranayam is all about balancing the mind. Of course, it is related with oxygen and carbon and other things in our body, but the main importance of pranayam is controlling, balancing the mind. Now, the functions of our respiratory system, the main function obviously is to supply oxygen to the body because oxygen is very vital for the survival of our body, of our organs, of the cells in our body. So supply of oxygen, that's the main function. And at the same time, removal of the carbon dioxide. Now this carbon dioxide is the metabolic waste in our body. So we need to remove it, and that's removed through the process of breathing out. Or in short, these two processes, like supply of oxygen and removal of carbon dioxide, they're called as purification of blood. So the blood purification, it takes place in the lungs, like addition of oxygen and removal of carbon dioxide. And of course, there are also self-protective functions of the respiratory system like coughing and sneezing. Something entering into the respiratory tract, we start coughing or we start sneezing. That's a protective mechanism. And the respiratory system is also important for talking because when the air is moving in the respiratory system, especially when you're breathing out, that produces vibrations and that can help us in the process of talking. Organs of the respiratory system, they are the nose, the throat, the larynx, the trachea with its banking system, and the lungs. This is a sketch of the respiratory system, schematic representation of the respiratory system. So the nasal cavity or the nose, from there the respiratory system starts. Then the part which comes is the pharynx or the throat in simple language. And then you can see one valve which is called as epiglottis. Now this valve, it always remains open and it allows the air from the pharynx to enter into the trachea. It's only when we are swallowing, when we are eating food, this epiglottis, it closes the trachea so that the food doesn't enters into the trachea. Otherwise, this epiglottis is open. So from the pharynx, from the throat, the air enters into the through the opening larynx, it goes down into the trachea and then it goes down into the lungs. This was in brief. We'll try to understand the important aspects now. Starting from the nose or the nasal cavity, as we all know that our nose, it is separated by a septum, and then we have two nostrils, the left nostril and the right nostril. Now it is interesting to note that at a given time we are breathing only through one nostril, or only one nostril is active at a given time. So breathing in and out either through the left nostril or breathing in and out either to the right nostril. Naturally, our nostrils keep alternating every 90 minutes. Roughly around 90 minutes, the nostrils change over. For 90 minutes, the left nostril will be working, and for the next 90 minutes, the right nostril will be working. And they will go on alternating with each other throughout the day. It's a different science from a yogic point of view. The effects of breathing through the right nostril, the effects of breathing through the left nostril, they are considered to be different. But that's not what we are going to discuss right now. From a medical point of view, what are the functions of nose? We can simply say that the functions of nose are warming the air. So when the air goes through the nostril, because of the friction, the air is slightly warmed up, and by the time it reaches the lungs, it is warm so that it will not damage the sensitive cells of our lungs. The cells of our lungs, they are very sensitive to extreme cold. So whenever the air is entering in our lungs, in our respiratory system, it is warmed up through the friction at the nose. So warming the air. And then of course there are minute small hair inside our nose. So this hair, they help in filtering the air. It keeps away the dust particles, it keeps away the carbon dioxide, the carbon particles from the air. They will be blocked because of this hair. So filtration of the air. And another important function is to keep the nasal passages moist so that the air which is entering inside the lungs is slightly having moisture in it. So when we breathe through the nose, the air is slightly warmed up, it is filtered, and the moisture content of the air is increased by the time it reaches the lungs. These are the functions of the nose, and apart from this, the other important function which everyone knows is the sensation of smell. So there are sensitive nerve fibers in the nose which are capable of sensation of smell. This is a cross section of the throat. Now there are various passages which open into the throat, and the throat area is the most vital area because the most vital passages, they are opening in the throat. So the first is obviously the trachea. It's opening or it starts through the throat. Then the esophagus. Its opening or its starting point is also the throat. Then the two nostrils. The backward part, the back side of the nostrils, they open into the throat. Our mouth, the back side of the mouth, it opens in the throat. And two tubes from the ear, the left and the right ear, which are called as the eustachian tubes, they open in the throat. For the ears, they are connected through the eustachian tube to the throat. So actually, there are 7 passages which open into the throat. The first larynx, which is mentioned here, is actually the opening of the trachea, you can say. Then the esophagus, the mouth, the left and the right eustachian tube, and the left and the right nostrils. So 7 openings, 7 passages, they are actually in the throat, and it makes the throat the most vital part, one of the vital parts in our body. Now, from the throat, the trachea starts. Now, trachea is a tube. It's made up of cartilage and muscles. And because of the cartilage and also because of the muscles, the tube is not a rigid tube. It's slightly elastic. So the length of this tube, it can slightly increase. The size, the diameter of this tube, of this trachea, it can slightly increase because of the cartilage and muscles being elastic. Now this single trachea, it runs down and it divides into 2 main branches, the left and the right. And the left and the right branches of the trachea, which are called as bronchus, they further go on branching and sub-branching to end in a structure called as alveoli. This is a simplified diagram for our understanding. So the larynx, the starting point of the trachea. So from the larynx or the trachea, as you can see here, it divides into 2 branches, one going to the left side, another going to the right side. The left and the right side branch of the trachea, they further divide into smaller and smaller sub branches. So you can just imagine a tree with a single trunk dividing into 2 branches, and those 2 branches they further dividing and subdividing into smaller branches. Now the smallest branch, the last branch, the end branch of the trachea is very microscopic, and at the end of this smallest microscopic branch there is a structure which is called as the alveoli. In simple language, we will call it as an air bag or an air sac. So there are thousands of them. This is all under a microscope. So the alveoli or the air sacs or the air bags, that's the area, that's the place where the exchange of oxygen and carbon dioxide takes place. So as you can see, over the surface of this alveoli, there is a fine network of capillaries, of blood vessels, through which 24 hours blood circulation is maintained. So when you breathe in, the air enters from the nose, goes to the trachea, to its branching system, and in the end, it reaches the alveoli. Now this oxygen from this air, it will enter into this minute capillaries into our blood, and the carbon dioxide from the blood, from these capillaries, will be drained inside the alveoli. So it's a two-way process. Oxygen from the air, oxygen from the alveoli, it enters into our blood, and the carbon dioxide from our blood, it enters into the alveoli, it is drained into the alveoli. And when we breathe out, this same carbon dioxide, it will be thrown out of our body. And then again, the process will be repeated. So the exchange of gases, exchange of oxygen and carbon dioxide is at the level of alveoli. So this is in short about the structure of the respiratory system. Now it's important to note that lungs, they are not a different organ, they are not a separate organ. All these structures, the branches of the trachea, the sub-branching of the trachea, the alveoli, and the blood circulation around the alveoli, all of these structures, they are enclosed in a bag-like membrane, and that complete bag, we can call it as the lung. And so there are two bags, the left lung and the right lung. So all this structure together is called as the lungs. Now talking about the process of breathing, we mentioned about the process, or rather we mentioned about the structure of the respiratory system. Now talking about the process of respiration. So basically respiration involves two processes, breathing in and breathing out. Breathing in is called as inspiration and breathing out is called as expiration. It's a muscular activity, it's by muscular action. So when we have to breathe in, there is a contraction of the diaphragm, the horizontal muscle dividing our body into the chest and the um, abdominal cavity, the horizontal muscle, the dome-shaped muscle, the respiratory muscle, it's called as the diaphragm. Now, this diaphragm or the respiratory muscle, because of contraction, it's pulled down. It's an active contraction of the muscle. And at the same times, our ribs, the ribs in the chest, the ribs in the thorax, there are 12 plus 12, 24 ribs. 12 on the right side, 12 on the left side, so total 24 ribs. These ribs, because of active muscular contraction, they are brought forwards and upwards. Or in simple language, we can call that the chest is expanded. So two things are happening. The diaphragm, the respiratory muscle, because of contraction, it is pulled down, and at the same time, the ribs, they are brought forwards and upwards because of the muscular action. Now, because of these two processes, the volume of the chest, it increases. And when the volume of the chest increases, the pressure inside the chest, the pressure inside the lungs drops down. It becomes negative pressure. And because of this negative pressure, the air from the atmosphere, the air from outside is pulled inside our chest, it's pulled inside our lungs. So that's the process of inspiration or the process of breathing in. Basically, the size of the chest is increased, the size of the rib cage is increased. And because of this increase in the size, increase in the volume available, the pressure drops down. And when the pressure drops down, the air enters in our lungs. Process of breathing in completed. Now, the moment the process of breathing in is completed, the process of breathing out, expiration, will start. For breathing in, the muscles are contracting. It's an active process because it involves active contraction of the muscles. But whenever a muscle contracts, it wants to relax itself. So, the diaphragm, the respiratory muscle, which had contracted, will try to relax. The intercostal muscles, which had contracted, which had expanded our chest, our rib cage, they want to relax. So, because of this relaxation of the diaphragm and the intercostal muscles, the chest comes back to its original position. And when the chest comes back to its original position, a positive pressure is created inside the lungs, and because of this pressure, the air is pushed out of the lungs. And this pushing out of the air outside the lungs is called as the process of expiration, the process of breathing out. Now, this process of breathing in and breathing out goes on alternately in our body. And this process is repeated around 14 times to 18 times per minute. Or the normal respiratory rate in human beings is 14 breaths to 18 breaths per minute. Practice of yoga aims at reducing this respiratory rate. If you're practicing the yoga, pranayam, yogasan practice, your respiratory rate will actually slow down. Now, the natural respiration is controlled by the part in our brain which is called as the medulla oblongata, which has described the process of breathing in and the process of breathing out. We have not described in detail about how the process is controlled. I'm just mentioning here that it is controlled by the part in our brain which is called as medulla oblongata. Now we will try to understand some few basic aspects of pranayam practice, or I would even simply call it as deep breathing practices. So to understand that, we need to know the lung volumes. Now actually, the amount of air which we breathe in, which we breathe out, it can be measured. It's a different science, but then definitely it can be measured. How much air we are breathing in, the quantity, the volume can be measured. So these are some measurements, averages of some measurements of our lung volumes. Definitely it's different for different people, depending on the age, depending on the size of the chest and the requirement. But on an average, these are the lung volumes. So the first lung volume is the tidal capacity, 500 milliliters of air. So a simple understanding of what is this tidal capacity. So just to simplify, Tidal capacity is the amount of air which we breathe in one single breath when we are physically and mentally calm and quiet. Like physically, we are just sitting calm and quiet, no work, no running, no jumping, we are just relaxed, sitting comfortable. And mentally also, we are not stressed. We are not having any tension, we are not having any anxiety, no stress. We are relaxed mentally also. So at that time, in one single breath, our respiratory system breathes in 500 milliliters of air, which is called as tidal capacity. And if we consider that the respiratory rate is 14 breaths per minute, just an example. So if the respiratory rate is 14 breaths per minute, and each time you are breathing in 500 milliliters of air, we can say that in 1 minute you are breathing in 7 liters of air. Okay, simple calculation. 14 breaths per minute, and in one breath you are breathing in 500 ml of air. So in 1 minute you require 7 liters or 7,000 milliliters of air. Now from this tidal capacity, immediately let us try to understand what is vital capacity. It is mentioned here 4,500 milliliters of air. So what is this vital capacity? A simple understanding for a common man. Vital capacity is the maximum amount of air which you can breathe in one single breath. So if you sit at one place and decide to take in a deep breath in that deep breath in, you can breathe in 4,500 milliliters of air in one single breath. That's called as the vital capacity. Now our lungs, they have a capacity of breathing in 4,500 milliliters of air in just one single breath. And actually what we are doing? We are breathing in just 500 milliliters of air in one breath. Now actually we can train our lungs to breathe in 4,500 milliliters of air in one single breath. That's possible by breathing exercise. Or in yoga, we will call it as pranayam. Pranayam is much more than the breathing exercise. But then still, if we just call it as breathing exercise, what we are doing? When we are practicing deep breathing, for example, 5 minutes every day. 5 minutes in the morning, we are practicing deep breathing. So during the deep breathing, what we are doing, in one breath, we are breathing in 4,500 milliliters of air. And every day morning, we are doing it for 5 minutes. But for the remaining day or throughout the day, what we are doing is we are breathing in only 500 milliliters in one breath. So when we are practicing deep breathing for 5 minutes, we are breathing in 4,500 milliliters of air in one breath. But for the remaining day, we are just breathing in 500 milliliters in one breath. Now, when you go on doing this practice continuously for a month, maybe 2 months, 6 months, 1 year, maybe a continuous practice, our lungs, of course, controlled by the nervous system, our lungs will start breathing in more amount of air in one breath for all 24 hours. The respiratory system or the nervous system will understand that you can breathe in 4,500 in one breath, and what you are doing is you are breathing in only 500. So the respiratory system or the nervous system aims at breathing in 4,500 milliliters of air in one breath and to follow this throughout the day. Or in other words, I am saying that our body tries to bring its tidal capacity equal to the vital capacity. But it's a bit difficult, or maybe up to a certain extent, I would say it's impossible. But then you can increase your tidal capacity from 500 slightly higher, maybe 550, maybe 600, maybe 700. This is possible for a common man. So our tidal capacity with the practice of deep breathing techniques, deep breathing practices can increase, say for example, from 500 to 700. Just a very nominal increase in the tidal capacity. Now, when you're sitting calm and quiet, no physical uh, or mental stress, worry, tension, instead of 500, if you start breathing in 700 milliliters of air in one breath, what would be its effect? If you remember, you're breathing in 7 liters of air in 1 minute. So that was your requirement for a healthy survival. So if your requirement was 7 liters of air per minute, and now you are breathing in 700 milliliters of air in one breath. So to get that 7 liters in 1 minute, you have to breathe only 10 times a minute. Simple calculation. Initially, you are breathing in only 500 milliliters of air and you are breathing in 14 times a minute to get your 7 liters of air in 1 minute. Now what you are doing is you're getting the same amount, 7 liters of air in 1 minute. But to get that 7 liters of air in 1 minute, you're breathing in just 10 times because in each breath, you're breathing in 700 milliliter instead of 500. So if your tidal capacity is slightly increased from 500 to 700, just a nominal increase which is possible for a common man, your respiratory rate has dropped down from 14 breaths per minute to 10 breaths per minute. Now, why to do this? Why to reduce your respiratory rate? You are saving energy or the energy requirement of your body for the process of respiration is reduced. Initially, the muscular action of the diaphragm, the intercostal muscles, it was 14 times a minute. Now it is only 10 times a minute. So 4 contractions and relaxations of the muscles of your respiration, they are reduced per minute. We can calculate if it's 4 contractions and relaxations less per minute, how many contractions and relaxations in 1 hour, how many in 24 hours, 7 days, 1 month, 1 year, and so on. So if you are reducing the contraction and relaxation rate of the muscle, the amount of energy which is required for this contraction and relaxation is reduced. Or in other words, you're getting the same amount of air through your respiratory system with less energy consumption. Or this is optimum utilization of the energy. The efficiency of your respiratory system has not reduced. The efficiency is the same, but you're getting that work done in less energy. So slowing down of metabolism from yogic point of view is not actually slowing down the metabolism, it is optimum utilization of the energy for basic activities. Our lungs are functioning, our heart is functioning, our kidney are functioning, our brain is functioning, our liver is functioning, the digestive system is functioning. But for this function, they are consuming some energy. Now, with the practice of yoga, the energy consumption for these vital functions, the energy consumption for these basic functions will be reduced. And again, I repeat, the energy consumption will be reduced, but that doesn't mean that the efficiency will be reduced. The efficiency will remain the same with less energy requirement. So that's the aim of yogic practices. I'm using the word yogic practices because it involves everything pranayam, yogasan. The effect, the overall effect of all of them will be less energy required. Now, talking about the analysis of gases when we breathe in and out. One more important aspect of pranayam. So when we breathe in 21% of oxygen, roughly 21% of oxygen, 79% of nitrogen, and say for practical purpose, 0% of carbon dioxide. It's a very nominal amount, but then for practical purpose, we would say 0%. And when we breathe out 16% of oxygen, the same amount of nitrogen, and 5% carbon dioxide. Nitrogen from the human point of view, it's a inert neutral gas. So we just breathe in and we breathe it out. It's not utilized through the process of respiration. But the main thing is we breathe in to get oxygen. But then when we breathe out, we throw out most of the oxygen back into the atmosphere. We breathe in 21% and we breathe out 16% of oxygen. Or actually, we are not able to utilize, we are not able to absorb all that 21% oxygen. Practically, it is also not possible that we absorb all that 21% oxygen. But then we are just utilizing only 5%. We take all the efforts, The diaphragm contracting, the ribs coming up and forwards, and all those things happening just to get oxygen. So 21% oxygen enters into our lungs, but while coming out, when we are breathing out, 16% oxygen is again thrown out. Of course, with that 16% oxygen, 5% carbon dioxide is also thrown out. Now, if we are capable of producing a slight pause, a slight stoppage in between the process of breathing in and breathing out, or in other words, I'm mentioning that if you hold the air for a bit longer time inside the lungs, the air will come in contact with the blood for a longer duration of time. And if it comes in contact with the blood for a longer duration of time, more amount of oxygen will be absorbed in the blood. So I'm talking about breath holding. When you hold your breath, the air, it remains in your lungs for a bit longer duration of time, and during that time your blood picks up more oxygen from the air. So in one breath, you're capable of extracting slightly more oxygen from the air. So when you go on practicing this breath holding for a few days or few months, a natural pause is developed in the process of respiration. Natural respiration is breathe in and breathe out. Breathe in and breathe out. Breathe in and breathe out. There is no pause. There is no holding. But when you start practicing this breath control, when you start practicing this holding of the breath, you go on doing it for a few days to month, our natural respiration will also develop a pause in between. Like breathe in, pause, breathe out. Breathe in, pause, breathe out. Breathe in, pause, breathe out. And if this pause in between is even for a fraction of a second, your blood can take up more oxygen. So pranayam practices, we can say it will help you to reduce your respiratory rate. It will help you to reduce the energy consumption required for the bodily processes. And at the same time, it will help you to pick up more oxygen from the air. And at the same time, if you are following the principles of yogasana practice, slow, gentle, steady, controlled movements, the oxygen requirement for all these movements, for all this work which is done by the muscles, is less. So overall effect is that your body is capable of working with the oxygen which is supplied with more efficiency, or there is more efficient utilization of oxygen by the body parts, by the body cells, and at the same time you are capable of getting more oxygen inside your system through the same number of breaths. So it's actually improvement in the functional capacity of all the organs. And then it is said that pranayam practices, they increase your lifespan. They increase your lifespan because it's the optimum utilization of the energy, it's the optimum utilization of the oxygen which is supplied to the body parts, to the body organs. So they remain healthier for a longer duration of time, their function is improved for a longer duration of time, and the wear and tear of these organs, of these cells, is reduced. So it is said the first effect, most of the books they mention that the first effect of pranayam practice, a proper pranayam practice, it can increase your lifespan. So here we just discussed very basic about the pranayam practices, like a very basic effect of holding the breath and a very basic effect of deep breathing practices. But then how it is beneficial to our body, that's what we discussed. So that's all for the time being related with the respiratory system and the pranayam practices. Hari Om.